Okay, so this is about magnetic dip and turning and acceleration errors. So the first thing to keep in mind is that this is a compass, all right, a compass needle. So the earth has a magnetic field like which is called a flux which keeps going like this, right? So it's like it goes like this and it goes down all the way to the south pole. So what happens at the equator is that the flux is literally parallel to the equator, all right? So what happens, there'll be only this force. It'll be like parallel to the equator. But as you go up, what happens? The flux is coming from the pole, right? So the magnetic compass needle will slightly bend downwards to the pole. So as you go here, it will just point towards this. So this is called magnetic dip on a compass. So this magnetic dip will cause you acceleration errors and also turning errors. When I say acceleration errors, there's a mnemonic to remember which is called ANDS in northern hemisphere. ANDS, ANDS. Okay, so the acceleration errors only happen when you're going from east to west. All right, east to west, only then you'll have acceleration errors. If you're going north to south, no acceleration errors. And at the equator, since there's no magnetic dip, there'll be no acceleration errors. All right, so how this ANDS works is that in northern hemisphere, if you accelerate a n, right, it will tell you you're going doing a turn towards the north. Same wise, in the northern hemisphere, if you decelerate, so A and DS, right, it will tell you that you're doing a turn to the south. On the southern hemisphere, it's the right opposite, and the mnemonics for this is SANDS, SADS. No, it's sand, just sand, 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 like the sand you get in the beach, right? So basically, this means SA, right? Accelerate in southern hemisphere, it will turn towards the south. Decelerate in the southern hemisphere, it will SAN, right? It will show a turn towards the north. So basically, for acceleration errors, it is ANDS in northern hemisphere and it is SAND in southern hemisphere. If you get confused between turning and acceleration, remember that ANDS first letter is A, acceleration errors first letter is A. So acceleration. All right, that's how you remember. And this only happens in the east to west when the flight is going from easterly or a westerly direction. It doesn't happen if you're going to north or south. All right. So next error is called a turning error. All right. The turning error, it is basically when you do a only when flying north or south this error occurs. All right, so basically when if you're going like this, if you're going this way or this way, if you're leaving the parallel of latitude and going towards north or south, this error occurs. So there's also a mnemonic for this. So the northern hemisphere mnemonic is UNOS, 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 UNOS. And for southern hemisphere, it is SUNO. Easy way to remember, like a Hindi word, suno. Suno, mere paas suno, or something like that, I don't know. So SUNO for the southern hemisphere and UNOS, UNOS for the northern hemisphere. So how it works is, if in the northern hemisphere, if you're doing UN, right, if you're doing a northern turn, that is maybe from 70-degree north lat to 80-degree north lat, you should undershoot me because it's UN, right? And OS, if you're doing a southerly turn in a northern hemisphere, you should overshoot. UNOS, right? OS stands for overshoot, S for southern hemisphere. So what this basically means is, let's say I'm at a 40-degree north latitude. I want to make a turn to the 80-degree north latitude. All right. So when I do the turn, what I do is I don't have to turn the aircraft until I see 80-degree north on the compass. No, because of the liquid and the compass swirl and the magnetic dip, what happens is that your aircraft will turn faster, but your compass needle will lag. So to fix this problem, what you do is, if you while doing this turn from a 40-degree north to 80-degree north, you will stop the turn earlier than 80-degree north. How earlier is that? There is a formula for that. 15-degree plus half of latitude. That means you're at 15-degree, right? So 15-degree is always constant. You want to go to 80-degree, right? So what is 80-degree? 80-degree by half, which is 40. So 40 plus 15, which is 55. So from going from 40° north to 80° north, you will stop the turn at 55° north. So then what happens after a while, the compass will, the lag will come all right, and you will be on the track which you're intended to. So it's again for same thing northern hemisphere, it's who knows, right? So you overshoot. So in this scenario, if you wanna go from 40° north to 80° north to 40° 40° north, this time you overshoot, meaning you want to go to 40, right? You go more than 40, which is more than 40 is what it will go come to 25°. So this is what it basically means. All right. So one thing to remember, at the equator there is no magnetic errors or anything. Turning errors only occur when you're turning from north or south, all right, and acceleration errors when you're going in easterly or westerly direction. So the mnemonics for acceleration error in northern hemisphere, it is ANDS, A and D S, and for southern hemisphere it is SAND, S A and D, all right. And for the turning errors, it only happens in north to south. When you do a north or a south turn, errors occur. The mnemonics are UNOS for northern hemisphere. UNOS, undershoot north, overshoot south. For southern hemisphere, it is SUNO, which is a Hindi word, SUNO. Southern hemisphere undershoot, northern hemisphere overshoot, SUNO. All right. And to know how much to undershoot or overshoot, you use a generic formula called 15°, which is always 15°, plus the latitude you want to go. That is 50°. If you want to go to the latitude 80°, then you divide that by half. So 15 into half of the latitude you want to go. So that is 15 plus 80 by half, which is 55. That's it. So that's in this chapter. That's all. Yeah.